We are going through exercise 13G, and in this video, we're going through question 1C, in which we have y equals log base 10 of a half x. So, as you can see, the only real way that this differs from your standard log graph is the fact that we have this half in front of my x. And what that's telling me is that we're going to have a dilation of a factor of 2 from my y-axis. But let's not worry too much about that. Let's just begin by finding my domain. So how do we find my domain? Well, we know that for a log graph, I can't log 0 or a negative number. So that means what's inside my brackets here has to be greater than 0. I can obviously divide both sides by a half. So what I'm going to end up with is x is greater than 0. And you can of course write that in a different way. You could write 0 to infinity. That's just as correct. So there are your domains. The next thing that we need to do is find my range, but I'm actually just going to hold off on this until we've drawn it, and it will become a lot clearer what my domain will be. The next thing that I have to do is find my x-intercept, To find my x-intercept, we let y equal 0. Whoop, that's not a very good looking 0, is it? Let me try that again. 0. So I'm going to end up with 0 equals log 10. Then I'm going to have a half x. Now, what am I going to do? I'm going to write it in index form in which I have a base of 10. 0 is my power. And then I'm going to have 1/2 x. Now, 10 raised to the 0 is 1. Then another way I could write this, hopefully you all agree with me, is like that. In my head, I like this better because now it's quite clear. I can just times this by 2, in which that is going to be my x-intercept. So my x-intercept is going to be 2, 0. Perfect. So we're nearly there. Let's start drawing what we've written here. The fact that my domain is 0 to infinity confirms what I already know, and that is that my asymptote is going to be at x equals 0. So let's draw that in. This is x equals 0. We then know that my x-intercept is going to be a 2 and 2, 0. So let me first give this a sketch this way. Whoa, that is perfect. I should have been an artist. All right, so now we're going to come over here. This right here is going to be 2. Actually, let me do this a bit smaller. 2, 0. Perfect. We can now obviously figure out what my range is going to be, remembering that my range is simply just all my y values. So it's obviously just going to be all real numbers. You can tell that by just looking here. It obviously exists for all my real values for y. Okay, so what do we have to do now? We now need to find another point. So hopefully I've gone through this in the past 2 videos. If you don't know the fact that we need to find another point, watch the last 2 videos. You need to find another point because what we've drawn right here is not specific enough to this. This could be true for a log with a different base. So I'm going to have to find another point. Another point. Whoa, another point. Let's find it for when x equals 4. So let x equal 4. So that means what we're going to end up with is y equals log 10. I'm going to put 4 into this. So it's going to be 4 times a half, which is going to be 2. Now I'm going to have to use my CAS calculator to solve this. We actually did this in the previous question, so we actually know what it is, but that's just because we've memorized it from the last one. But in real life, you would have to go, all right, I'm going to have control log a base of 10, then a 2 there, then control enter to get my approximate 0.301 is going to be my answer. So I come over here and I write 0.301. So that means I come over here now and I'm going to say this is 4. And again, my graphs are not to scale at all. This is going to be 0.301. This point right here. Okay, there we go. Let's pretend those lines are straight. And now that we have 2 points, it is now specific enough to this question. So we are now done. We have my range. We have a second point. Everything is right in the world. Hopefully this was helpful to you in answering this question.